calculations on the data sheet on two specific labs, which are 3A and 14. 3A was the kinetics involving the iodine, acetone, and one other thing, I forget. And then 14 involved KSP and pH of bases. And a writing assessment is coming up, and it will be included in the final exam, but I'll let you know the details ahead of time so that you can write it up. It'll be a very short writing assignment. It'll be like from like a half a page up to 1 page, really just a few paragraphs max. And the value is 2% added to the final exam score. And the instructions will be posted in Blackboard. And the purpose of it is for the department to get some kind of measure on the writing skills of the students across the board. Like the entire school is doing this. So it's not like an English essay or anything like that. It's just to get a sample of your best writing, like something that's thought out and put down and short. It's not at all like looking up information like a biography and writing about that or any like some kind of research papers. It's very short. And anyway, I'll put instructions on that on Blackboard here this week. Okay. By the way, are there any questions on the labs or the exam?
Mic on.
Okay. Okay, chapter 21, number 6. Oh, yeah, looks like I forgot that one. Yeah, that's MC squared. Yeah, I'll let everyone know that. Yeah, that's the Einstein equation, where energy converts to mass and vice versa. There's an example of that in the class notes for the chapter. And also, some questions popped up about this Duracell problem. Does anyone have questions about that?
I left it blank too.
Here. I'm just lost.
Same.
Well, okay. Although in the class notes for the chapter on electrochemistry, I think the last one, it has an example a whole lot like this. Were you aware of that?
Yeah, I stared at it and I just.
Well, in the other class notes, the curves are pretty much identical except for the little label, right? And instead of like this one here, instead of saying 1C, 2C, 3C, it'll say, it'll have a number here, right? Like some number of milliamps. Yeah, I don't have it handy, but okay, so 1C is actually a measure of current. And then the example says, let me reduce it back down to its size. It says here it's talking about the 1C rate. And it says it's defined as draining the full capacity in 1 hour. So for a 400 milliamp hour battery, it'll drain all 400 milliamp hours in an hour, which means the current must be 400 milliamps, right? If we take 400 milliamps times 1 hour, we get 400 milliamp hours. So if we have something slower than that, like 0.4C, that would be 0.4 times 400 milliamps, which is 160 milliamps. So each of these curves is actually corresponding to a current, even though it's labeled 1C, 2C, 3C, et cetera. It actually means a current. 1C in that case would be 400 milliamps, 2C would be 800, 3C would be 1200, 0.1C would be 40. This curve here would be 40 milliamps. This one, 0.2C would be 80, and so on. So each of these curves just corresponds to a different rate that the current's being pulled out of the battery. Does that help explain it a little? Well, if person has the answer to part A, then they know like how many milliamp hours is in the battery, right? Well, okay, so if we know how many milliamp hours there are, we can find out like what it is in milliamp seconds. And an amp is a joule. I mean, an amp is a coulomb per second. And then we have a mass of silver. We know how many from this part A, we know milliamp hours. From that, we can get coulombs, moles, which can be related to moles of electrons and moles of silver and so forth. I'll just send that sort of out to everybody as a hint in case they're also stuck on it and they weren't able to watch this.
Thank you.
Okay. They have pretty colorful graphs. Okay, any other questions? Oh, okay. These questions are similar to It's the same set of notes that the Duracell example is in, where it goes through similar problems step by step, although the problems in those cases are worded a little differently, but it's essentially the same process. Okay, is anyone else spinning wheels on this, part number 1 and 2?
Yeah, I am
Yeah, I'm
too.
locked on 'em.
Well, okay, this one, the first one, is there's a half cell. Okay, 1/2 cell is the standard hydrogen electrode, so we know what's going on there, right? It's H2 and H plus, right? We know that from the table of standard potentials. And the other half cell contains silver wire, but we have other stuff going on there. In addition, that half cell contains 0.01 molar HBr. Okay, so we can, I don't know if that turns on any light bulbs or not. We have solid silver in the electrode. We have AgBr attached to it, and then this AgBr solid is in contact with bromide ion. It's a lot like the examples that were posted. It's just that we're solving for different variables. And the same goes for number 2. In this case, we have hydrogen gas at one electrode, and it also contains HCl and the pH is given. So both of these involve the Q, you have E equals E0 minus 0.0257 on N log Q, natural log Q. Yeah, so both of those involve that sort of stuff. I'll send that one out too, since others may not see this. Were there any other questions? Well, there are energy level diagrams in the last online class. Like we're on the silent PowerPoint video has a bunch of them. Have you tried checking that? Okay. Yeah, the energy level diagrams depend on the shape. We have 3 different shapes we were dealing with. There's an octahedron, and then there's a tetrahedron and a square planar. Yeah, and the way they are organized depends on the shape. Okay, how about the nuclear stuff?
That's the only part I kind of get.
Okay. 3 different answers, and they all happen to match one of the given.
Yeah, because A, B, and E are pretty close.
Okay. Just be sure to show your work. Like, don't just circle one and leave it blank. Just be sure to show the reasoning. Okay, well, we could look at the class project. Are there other questions on the exam? Okay. Okay, I guess we'll go ahead. Sounds like there aren't other questions. Okay, so let's see where. Yeah, okay, so let's look at the class project. Okay, the PDF on Blackboard, which describes the project, was revised. This is a new version. The changes, there were a couple of changes. The weighting was changed, and it's because the step involving comparing the residues is turning out to be more involved than anticipated, so the weight was reduced from 20 points to 10 points. And the due date was extended. The due date was this Friday, and now it's next Wednesday, the 13th. That's a last day of finals week. So you have until midnight on the 13th to turn it in. And then another change is that this PDF was uploaded, and it has a bunch of tips for working on this project. And the first is finding a spike protein, and that involves starting with the database. And I've been using Uniprot, although it's not like required to use Uniprot. There are others like Blast, for instance. So, but my examples here revolve around Uniprot. So this is their home page. It's at uniprot.org. And at the top of their home page is a search box. And let's see, I can go to that page here. See, this is their second page. This is their home page. So up at the top, there's a search box, and I'm going to type in spike protein corona, and I could follow it with something like avian or equine, human, or some species. We'll just leave it general for now. So I hit enter, and we get a list. It's a fairly long list. There's 7,500 hits. And so here's the list. And what we're comparing to is a COVID-19 spike protein, and it has a length of about 1,250 or so residues. So we want to have a look in this length column over here for something that's fairly close to that, like, give or take 50 or so, or maybe 100 at the most, but something that has a reasonable chance of lining up well. So this first one is the human Sars coronavirus, and its entry number is P59594. So we're going to click on that. Okay, and now it pulls up all the info for that protein, and you really don't really need to know any of it. It's really all about biochem and stuff until we get down to the actual structure. Here's a model of it that you can twist and turn and look at. You can show it off to your friends. Might be even able to zoom in. Expand.
Mic off.
Collapse. Okay, well, that was cool. Okay, so let's go down. Oh, look, when you do a mouse wheel, it highlights different parts of it. The different colors correspond to different functions. Like one part of it attaches to the cell and sort of tricks it into opening up so that the virus can inject its DNA inside. This describes the regions, in case you're interested. Now the part we're looking for is this. This is the actual sequence, and it's numbered starting from 1 up through 10. And each row contains 50 residues. And it goes all the way down to the end, which is 1,255. So to find out if this is a suitable residue, we could go back to this tips document, scroll down to the part that talks about aligning your sequence. Okay, so we're going to align that sequence to the COVID-19s, and the COVID-19s is pasted into the Excel file, and it's also pasted right here, so it makes it real easy to copy paste. It can be aligned manually, but please don't do that. That's a whole lot of work. There are online tools. One of them is XSpace's sim tool, and it is, let's see, first I'm going to copy this. We'll have to paste that in, so I'm copying, whoops, missed 3. I'm going to copy the whole thing here. There, did a Control C to copy, and now we're going to XSpace sim tool. So we're going back here, and here is the XSpace sim tool. Going to reset it since I used it just a little while ago. Okay, so the first sequence is what we would want to compare to, like the one we just looked up. The sequence 2 can be the COVID-19. I'm going to paste that in there. So there, at copy pasted all of it. It's good to check that the beginning and the ends are there. I know it starts with MFV. and it ends with HYT, so it looks like everything copied in. And we can give this a name, otherwise it'll just keep calling it the default user sequence 2. So I'm going to type in COVID-19. And then the other one, which we want to compare against, that's human SARS, is P59594. So I'm going to copy that label, go back to the sim tool, and then paste that in where it says the Swiss protein label. So that's 59594. Oh, and by the way, in sequence 2, we have to check the user entered box, or that little radio button there should be marked. So we have it all set. It's going to compare P59594 to the COVID-19 sequence, which was pasted in. So down at the bottom, we have this little submit button. So we're going to click submit. There, and now it shows the difference. It looks like it ended up with 1,277 residues overlapping. So it goes all the way down here. And there are a whole lot of stars, which is good. A star means that they are identical. So see in the first, at the top of it, COVID-19 starts with MFV. The other one starts with MFI. So the first two residues have a star, meaning they match, and then I and V didn't match, so there's no star. And then in some cases, it was necessary to insert dashes here to make them match up because there's a gap in one or the other. In this case, the COVID-19 needed dashes inserted, and in this case, the human SARS needed dashes inserted. Are there any questions?
Mic on.
Okay, well, we'll get there. Okay, we'll get there really shortly here.
Mic off.
Let me copy paste this whole thing. Copy paste this into Word. Doesn't have to be Word. This is something I was working on earlier, but I'm just going to delete all of that and paste this in. Okay, I'm going to mark it original. And then, so it can be referred back to, and then hit a line break or page break, Control Enter, and then paste it again here and actually edit it. And the goal is to get the entire sequence for one protein and then the other. So this is kind of tedious. It involves deleting like everything that's COVID related and all the stars and blanks, and just going down the list like this until it's at the end. There might be easier ways to do this, but this one is simplest, I think. I mean, easier in the sense, I should say faster. This one is, I think, the easiest to follow. Okay, so now we have everything in there that's specific to the human coronavirus, P59594. We have the entire sequence, and now we need to get rid of the stuff that's on the left-hand end of it. All those labels need to go. So just go down the list and delete them. There's a text editor that's open source that's called Emacs that makes all of this stuff really easy. It makes Word look really basic and weak. It can do about anything. It can record macros, and so if you wanted, like the stuff I'm doing now, you could record a macro for it, and then it'll save it and then repeat it any number of times and do what I'm doing in like a fraction of a second. Okay, so now, now we have the sequence that's all by itself. So I'm going to save this off. Okay, and now string this into a continuous set of letters. Okay, so basically this involves going to the right-hand end and hitting delete and doing that over and over again. Okay, that should do it. And now let's highlight the whole thing and go up to here. This is a review tab in Word. Go to word count and just make sure. Yeah, it says there's 1,277 characters without spaces, which is correct. So we didn't like accidentally delete anything. Okay, so copy this, and then this whole thing is what gets pasted into Excel. So we go to Excel, and here's a spreadsheet. And we're going to paste that string in. Okay, there it is. Okay, now the object is to get that into a column. So if I go to the COVID-19 tab, here's the string for COVID-19. Here it starts with MFV, and it's converted to a column here, MFV, and so on. If you need to get to the end of a column, or well, of a column, you go end and then down arrow, and it goes down to the end. So this ends at row 1313. I'm going to go to end, up arrow to the top, and see it starts in row 41. And the way we get it from a horizontal string of letters to a vertical column involves first parsing this out into separate columns, like put an M in column A, and then put the F in column B, and so forth. Something doesn't look right, actually. This should start MFV, or wait, no, this is the other one. This is MFI. This is okay. So how do we get it from the way it looks now to one letter in each column. Does anyone out there know?
Mic on.
Okay. Normally we'd use the text to columns here, but I think that requires a delimiter, which we don't have. Yeah, it doesn't look like this is going to help. So let's check online and see what we can find. Here's Excel data text to columns, and there are lots of Excel tutorials on YouTube. Most of them are really helpful. The problem is that we don't have any blanks between the letters, and that makes it a little difficult. You can try checking one of these. I did it before, but actually, I don't really remember how I did it. So let's check this.
Mic off.
Here it says use text to columns, but we just looked at that and it doesn't fit. Yeah, I don't think. Yeah, I don't think this is going to help. But anyway, so that's one of our things. The things I'll need to look into is how I did that. But just to continue on, though, for now, let's go to the COVID-19 sequence. And we could use that like for tonight if we wanted to, but I don't think most of your questions revolve around that. We could copy paste this entire
Mic
column
on.
in, but that's actually the last step of the whole thing. There are other parts that are more important that come first. So let's look at those now. And did any of you have specific questions about editing this main sheet, or you just want me to go through it from the beginning? Hello? Oh, oh, good. Okay. Yeah. Here? Yeah, you mean this? Yeah, that's just test stuff. Yeah, that was just put in there to test with. Yeah. Yeah, or input whatever you need to test your 20, like just to make sure it all works. Was this if statement edited to cover all 20 residues? Okay, the tips document describes that in pretty much detail, but we can go through it now. Let's add one residue. Like it looks like this points to amino acid formulas A14. So if we go to here, amino acid formulas, and then cell A14, so it's pointing to this G, and the formula is in here. So yeah, so there's G and there's the corresponding formula, and it's referenced back on the main page. So here the formula is pointing to E14. So it's A14 and E14. So if we copy this and paste it, that'll give us the next one in the list, which is H. And there's the formula. So H is pointing to the other tab in the next row, which is 15. And it did the same thing for the formula. So now let's edit this if statement so that it includes this new residue. So if we have a look at this formula, it's looking at G21, which is, here's G, and there's 21. There's a 1 in that cell, so it's looking at that and it's saying, okay, is that a 1? And then if yes, then it compares to, then it looks at B21. Here, B21 is an A, and it's comparing it to A6, which here, if we go up here, A6 contains an R. But anyway, basically what it's doing is it's looks here and checks for a 1 or a 0, and if it finds a 1 there, that means there's a difference. So then it looks at A and compares it to the entire list of residues to find out which one it is, because it needs a formula. So it's basically looking down this list until it matches up to get the right formula. So we need to extend that to the next residue, and it's easier to do this in an editor like Word. So let's paste that here. And I don't like normal fonts for this because it pushes all of the punctuation together. So it's easier to see these if something like Courier is used, and then make it larger so it's easier to see. Courier uses the same amount of space regardless of which character it is, so it doesn't like squish the parentheses together. So we need to add right here. So if we take, like, copy this part, copying one like complete if statement from an open paren to the closed paren, and then we're going to replace this set of quotes with that. So I just pasted it in. And so now we need this to say if B21 is equal to the next one in the list. We were looking at A12, now we need A13 and B13. And that's it. So we copy that and then go back here and paste it over the original, hit enter. So now the formula has been updated for H, the next residue, which is in row 13. So we've done half of this. The other half involves the residue that's being, or the protein that's being compared to. So let's do the same thing with it. So go and choose Courier make the font larger, and then copy the innermost if, and then overwrite the inner double quotations, and then change from 12 to 13. And copy the whole thing. And then go back and paste it over the original. There, so now we have the correct formula in H21 and also in I21. So then copy this and then paste it over there. So now each of these cells contains the updated formula, and it's good for the first 9 residues. And we can test it by entering an H somewhere. So here, let's say that instead of E and E, that one's an H. So let's put an H here. And you see it worked because the 0 changed to a 1, and now it shows the formula for H. So these 2 cells match, this one and this one. They display the same formula. And we were comparing an E to an H, so this on the left side in this column, that should be displaying the formula for the E residue. We can check that. I compare these 2 cells. See that they do contain the same formula, so they match up. So it looks like things are working for our new residue. Eventually, it'll be necessary to move these down to create room and just highlight the rows and then right-click and choose Insert, and it'll add for you. And sometimes it drags the graph along with it. So you have to move it back up where it was. So this gives more room for the other 20 residues. So we could do the next one. There's the next residue. I just copy pasted down 1 row, and then we do the same sort of updates in this cell and this one, and then copy paste them down again. Okay, are there any questions?
Mic on.
Okay. All right, let me copy it to match you. There, so it ends at V. Okay. Yes. Yes. Oh, after you're familiar with doing it a couple of times, it should be okay to go do all the rest in one fell swoop. I'm overriding them. Yeah, it's one of the things about the font that if the font's not something like Courier, it gets really tricky because sometimes double quotes look like single quotes. Sometimes they're really close together. So this way it makes it more obvious. Like for instance, the next one in the list we do here would be that. Let me zoom in just to make it easier to see. So we copy the innermost if statement. See, it starts with if, then it has a full set of parentheses, and open and then a close. Everything in between is copied, and then highlight the two quotation marks and then paste over them. We could delete them and then paste as well to get the same effect. And then we go back and bump up the 13 to a 14 like that. So that's how we get the next one. And then we take this, the whole thing, and then go back here to the very first one that's in row 31 now. And then get rid of the old one. We could highlight it and delete and then paste in the new one and then hit enter. And then the ones below it are still old. See, they end at 13 all the way down. The top one goes to 14. So we need to copy it and then paste it down. Oops. Something messed up. Control C. Oh, it's working. It's just that there's nothing in my list that it can't pull the formula. That's why it's pulling a blank. Okay, so I just undid my stuff, but are you all following what I did, or do I need to explain something better about the last thing I did? No, almost the same. These, I click up here where the formula is, and it'll show where it's looking. It highlights the cells it's looking here in G31. It looks at this 1, and it's also looking at this A and B31. And if we do the same, hit escape to get out, and then click in the other formula and go up. See, it's comparing the same one, but to a different residue. See, this one's comparing the other spike protein residue in this column D. It's comparing all of these. Well, actually, it's comparing this one, whereas the COVID-19 is comparing A. So the if statement here on the left looks at A, and the if statement on the right looks at R. And they're different, so it's actually displaying the formulas for each. But if they were the same, like if I change that R to an A, then this formula should disappear like that. Or if I put an E there, then they show up again. So once this is working for all 20 residues, then it's fine to paste in the entire residue. Or I mean, the entire sequence all the way down to like all 1,200 and something letters. That's right. It can be just pasted down. And there's a pretty handy tip in this in that PDF about copy pasting. It makes it pretty easy. See, it's down near the bottom. Well, somewhere. Oh, here it is. It has a link to the tutorial on YouTube. So basically what it is, for instance, what if I wanted to copy this G all the way down to the end of this column A, and the end of column A is it's 1303. If I wanted to quickly do that, one way is to copy this, Control C, and then highlight all the way down to 1300 and something, and then do a paste. That's one way, but there's an easier way, and that is copy it, and there's a little square in the lower right hand corner of that box. I think we right click on it, or I forget, but it'll automatically do it. The details are on this YouTube. We could, it's really short. It's only a couple of minutes. We could have a look. I don't know if you'll be able to hear the audio, but it shows in detail what to do. I'm just curious, Brennan, can you hear the audio of that video? Oh, okay. She has a nice English accent. Just FYI. Okay, it was this. No copy was even needed. It's just highlight the cell, like in that little green box at the lower right corner. She said, double click it with the left mouse button. There, and it filled. There, copy G's all the way down to the end. There, so we have all of our G's. So that makes something that could be kind of tedious very easy. Okay. Are we okay on this? Are there any more questions? Just to have a look at what the graph would look like, we could paste in COVID-19, just use it as a test case. I'm going to copy all of it. I'm going to paste it here where all the test stuff was. So see, for some reason not sure why it made this row so tall, but anyway, I'm going to bring it back up so it looks like the others. Okay, and then we don't have another sequence to compare against, so I'll paste the same thing over here. Whoops, I have to copy again. There, so now we'll paste it there. So we have two identical sequences. And now we need to copy the codes down so we can do that tip that was in the tutorial on Excel. There's a little green box. Just double click on it, and that copies the code all the way down. And now we can do the same for the other formulas. Just double click that box there. Now, so we have everything there. So columns B and D contain identical sequences. So all of the diffs are going to be 0 there. So in F and G, we're just going to have a bunch of zeros, and none of the formulas will show up because everything's the same. So, but to test this, let's change this L to an E. See what happens. Oh, I forgot. I need to update these if statements to make this work. Yeah, so these if statements aren't really going to work because they're too short. It needs to go all the way from 13, where we left off here at 13. It needs to go all the way to 24. Yeah, so the if statements would need to be updated. And once they're updated, then they could be copy pasted all the way to the end. And then that's what would show up in this graph after extending it, the x-axis out to 1200 and something. Should ideally be a whole bunch of zeros and a relatively small number of ones. Okay, are we all set on this? Okay.
Me either.
Okay. Okay, what are those? Okay, which lab was this?
$23.
Okay. Yeah. Well, on line 14, that refers to the overall reaction. And that's generating H2 gas. Yeah, so in the table of standard potentials, one of the standard hydrogen electrode has a reaction that takes water and then generates hydrogen gas from it. It's the reference point. It could be oxidation or reduction. In either case, it's zero. But in this case, it's converting water to H2. Well, the copper, well, the, okay. Yeah, the copper in that case is being oxidized. So we have copper going to Cu2 plus. See, that's yeah, it's well in the case of part one, that's generating hydrogen gas. So you should have H2 on the right-hand side and Cu neutral on the left-hand side, water on the left-hand side. And since the copper is being oxidized, you'd have Cu2 plus on the right side, and then that would be balanced. And it'd be balanced in this case, then it's like basic, because yeah, if we're taking water and generating hydrogen from it, the difference is OH minus. Here, let me double check. Well, what about on page A-6 at the bottom? Yeah, that's the one. Yeah, the one I mentioned, actually I should have mentioned the one at the bottom of A-6, because at A-6 we're converting water to H2, whereas the other one we're not. We're taking H plus to H2. Well, and like part B, for instance, the observation at the anode is a silvery metallic solid is formed, right? Right. And if a solid forms, that would mean it's forming neutral tin. So it's taking the tin out of the solution, like meaning the ion, and then adding electrons to it until it's neutral. So the at the anode, the SN2 plus would be reduced to neutral tin. So that would give you one half reaction. And the other one would have to involve an oxidation, because the tin is being reduced. Therefore, the other reaction has to be the opposite, and that one involves chloride and chlorine gas. And like in the case of part A, we have well, the observations are bubbles at both electrodes, so that tells us that gas is being formed at each, right? Oh, okay. Well, in part D, that one has observations of bubbles at the cathode and copper forming on the surface at the anode, and that's kind of like the tin one that we just looked at. Only the difference is what's going on at the cathode. In this case, at the cathode, it's a water-based reaction, and it's generating a gas. So if we have water and we're generating a gas that's either hydrogen or oxygen, and they occur in different environments, like one's acidic and the other's basic. At the cathode, yes. The anode would be the negative.
Wait, I thought it was reversed for
Oh yeah, I
electrolytic
think
cells.
now that I think about it, yeah, I think they switched the poles on this to force the reaction.
Yeah, because
Normally,
for the galvanic, it's the other way.
yeah. Yeah, in this case, yeah, the way it's labeled minus is where reduction would occur. Like for part D, at the minus electrode, that's where the copper gets reduced. Okay, are we all set on that? On experiment 23?
I have another question about the exam.
Okay.
Okay, so I'm looking at chapter 21,
Mic
question
off.
12, and I have no clue where to start.
Let's see, that is here. Chapter 21, did you say number 12?
Yeah. Last one, I think.
Oh, that's like one of the questions in the chapter 21 class notes.
Okay. I'll go search for that then. Thank you.
Okay. Any other questions?
Mic on.
Okay.
Mic off.
Okay. Well, I'll send out an email that mentions the things about the exam that we talked about so that everyone knows. Okay. Well, if there aren't any questions, I guess we're all set. I'll go ahead and stop this recording.